Hello everyone, welcome back to Chapter 5. Today we will focus on Unit 3, Digital Currency and Blockchain. Let's have a quick review on last video. Last time we first introduced how to retrieve web pages from websites. Next, we introduced cookies and explained session cookie and persistent cookie separately. Finishing reviewing the last unit, let's start today's unit. Digital currency exists purely in a digital format. It has no physical form unlike conventional fiat currency. For example, the money you can see in the slides are fiat currency. Digital currency is an accepted form of payment to pay for goods or services. As with cash or credit debit cards, digital currency can be transferred between various accounts when carrying out transactions. It has made it possible to bank online, for example using PayPal, or via a smartphone app, for example Apple Pay. This is all possible because money only exists as data on a computer system, but it can be transferred into physical cash if we need it. Digital currency relies on a central banking system. For example, suppose Nick wishes to send Irina some money. Nick uses Bank X and Irina uses Bank Y. The problem with centralization is maintaining confidentiality and security. These have always been issues with digital currency systems. However, one example of digital currency, known as cryptocurrency, has essentially overcome these issues by introducing decentralization. Cryptocurrency uses cryptography to track transactions. It was created to address the problems associated with the centralization of digital currency. Traditional digital currencies are regulated by central banks and governments in much the same way as fiat currencies. This means all transactions and exchange rates are determined by these two bodies. Cryptocurrency has no state control and all the rules are set by the cryptocurrency community itself. Unlike existing digital currencies, cryptocurrency transactions are publicly available, and therefore all transactions can be tracked, and the amount of money in the system is monitored. The cryptocurrency system works by being within a blockchain network. Blockchain is a decentralized database which stores all transactions of networked members. Essentially, the blockchain consists of a number of interconnected computers, but they are not connected to a central server. All transaction data is stored on all computers in the blockchain network. Whenever a new transaction takes place, all the networked computers get a copy of the transaction. Therefore, it cannot be changed without the approval of all the network members. This effectively removes the risk of security issues such as hacking. Blockchain is used in many areas, not only cryptocurrency we have mentioned before. There are smart contracts, pharmaceutical research, politics, education, and so on. First, I'm going to introduce one application of smart contracts. The core requirement of insurance companies is a formal agreement with the insured person that guarantees coverage as the documented terms. Besides this, they also need to manage the claims arising from various incidents and life events that trigger the activation of the agreement. Smart contracts can execute this entire business process from creating the formal agreement, its issuance to the insured, till the settlement of claims in case the policy features need to be executed. Second, I'm going to introduce application in pharmaceutical industry. When a factory produces a new product, they will create a unique hash and assign it to the product. The product will be registered on the blockchain using its hash, unique ID. The product will be considered as a digital asset on the blockchain network, and its hash will be used to track it anytime on the world network. Once the product is registered to the blockchain by the manufacturer, Its ownership will be easily transferred to another participant using a user-friendly mobile app. Let's say the wholesaler wants to purchase the drugs from the manufacturer. Manufacturer will physically transfer the drugs to the wholesaler, and the transfer transaction will be registered to the blockchain simultaneously. Wholesaler will repeat the same process to transfer the drugs to distributor, and distributor will do the same business with pharmacy. In Figure 1, the basic structure of the blockchain-based pharmaceutical chain management is given. Now, let's consider Dr. Alice needs some drugs, and he wants to purchase it from a pharmacy. Using the mobile app, Dr. Alice will first query for drugs ID to convert all of its journey from manufacturer to the pharmacy. If the product is genuine, mobile app will show all of its history, and if the drug is counterfeit, no record will be displayed. Once Dr. Alice is sure about the originality of the drugs, he will then purchase them. Same as the doctor, other participants, for example nurse, family, and patient, will also be able to track the journey of the drugs. Third, I'm going to introduce some applications in politics. Smart cities. Blockchain enhances data management in smart cities by ensuring secure and efficient infrastructure for applications like energy management and transportation. Central banking. Blockchain provides a transparent, accountable, and efficient alternative to traditional banking systems, reducing corruption and enabling real-time payments. Government procurement. Blockchain streamlines government procurement by creating a shared, tamper-proof record of transactions and enabling automated smart contracts. Digital identity management. Blockchain secures digital identities, reducing fraud and the cost of identity verification, while providing convenient access to services. Land registries. Blockchain creates immutable and transparent land registries, preventing illegal property transfers and streamlining various governmental processes. Validation of qualifications. Blockchain simplifies the validation of qualifications by creating a shared, tamper-proof record, making it easier for employers to verify credentials. Last, I'm going to introduce some applications in education. Record keeping. Blockchain enables automatic verification and secure storage of educational documents, reducing the need for laborious background checks by employers. E-transcripts. Blockchain facilitates tamper-resistant, efficient production and sharing of academic transcripts, saving time and reducing fraud. Then centralization of the institution. Blockchain supports a new business model for universities by automating agreements and payments, enhancing security and reducing administrative costs. Financing education. Blockchain manages teacher wages and student scholarships transparently and equitably, improving financial accounting in educational institutions. Copyright protection. Blockchain securely stores and tracks the use of copyrighted content, preventing plagiarism and ensuring proper access to instructional materials. Whenever a new transaction takes place, a new block is created. A new hash value is created each time a new block is created. This hash value is unique to each block and includes a timestamp, which identifies when an event actually takes place. We will now consider what happens when a chain of blocks is created. Figure 5.9 shows part of a typical blockchain. It is clear from the figure to see how these blocks are connected. Block 1 is known as the genesis block, since it doesn't point to any previous block. Now, suppose block 2 is changed in some way. Any changes to the data within block 2 will cause the value of the hash to change. It will no longer have the value 6AB1. This means that block 3 and beyond will now be invalid, since the chain was broken between block 2 and 3. Previous hash 6AB1 in block 3 is no longer valid. This will prevent tampering, for example by a hacker. However, it may be crossing your mind that computers are now so fast that it should be possible to quickly create a whole new string of blocks, and therefore recreate a new chain before the problem has been discovered. This is prevented by proof of work, which makes sure it takes 10 minutes to determine the necessary proof of work for each block before it can be added to the chain. This is policed by miners, which are special network users that get a commission for each new block created. Thus, the whole process of creating new blocks is slowed down, which foils hackers, and also means that the currency is regulated by all the network computers. Consequently, this makes it almost impossible to hack into the blockchain, since it would be necessary to attack every single block in the chain at the same time. It only takes one block to break the link for any transaction to be terminated. When a new block is created, it is sent to each computer in the blockchain and is checked for correctness before being added to the blockchain. If a new network user is created, they get a copy of everything in the whole blockchain system. Finally, it's about the end of this video. Let's have a quick recap of this unit. First, we introduced what digital currency is and why we use cryptocurrency instead of traditional digital currency. Then, we introduced what cryptocurrency is. Second part, we focused on blockchain. We introduced what blockchain is and the application in different areas. Also, we talked about how blockchain works. That's all for this video. Thank you.